Okay, let's consider this problem. So two particles 1 and 2 move with constant velocities v1 and v2 along two mutually perpendicular straight lines towards the intersection point O. Okay, let's draw it. So let's say one particle is moving this direction, right? So let's say v1 is moving into mutually perpendicular direction v2, right? And let's say this is the positive y-axis, this is the positive x-axis, and the particles are located at the distances L1 and L2 from the point O. Okay, these are the direction of the velocities. Now we consider the location. So let's say this is the intersection point O. One point is here, one point is here. This distance is L1, which is coming V1. This distance is L2, it's coming at V2. So all constant velocities. How soon will the distance between the points, distance between the particles, from the smallest, and what is it equal to? Okay, so as a function of time, we'll first of all find out what is the distance between the two particles. Okay, so now after time t, the horizontal, the let's consider one. Sorry, let's consider one particle to be A, other particle to be B. So the distance AO after time t, right? AO will be equal to L1 minus V1t. PO will be equal to L2 minus V2t. Distance is decreasing, right? I mean, till it coincides with the intersection point, the distance is decreasing. So L1 minus V1t, L2 minus V2t. So AB root over A square plus B square with Pythagorean theorem. So AO is minus V1t whole square L2 minus V2t whole square. Now what they are saying is, when will this AB become the smallest? So for convenience sake, so basically AB to be minimum, right? This means AB, okay, AB mod AB basically, or okay, obviously AB is the distance, sorry, my bad. So AB has to be minimum, so AB square also has to be minimum, right? So DAB square, the variable over here is time, so T should be equal to 0. So if we differentiate it with respect to time, what happens is first term 2 1 minus v1t into, then differentiating it with respect to time, so minus v1. Similarly 2l2 minus v2t into minus v2 to 0. Minus minus cancels out, 2 cancels out, this becomes L1 v1 plus L2 v2 t times v1 square plus v2 square. This means time taken L1 v1 plus L2 v2 divided by v1 square plus v2 square. This is basically the instant of time when the distance is minimum. Now what is the minimum distance, you ask? That is AB. So we just substitute AB at AB minimum, just substitute this T root over, okay, let's call this as T minimum. Okay. So AB minimum is equal to root over L1 minus V1 T minimum whole square plus L2 minus V2 T minimum whole square. So L1 minus V1 T minimum is nothing but L1 minus V1. So I'll just try to multiply. Yeah, okay, fine. So L1 minus V1 T minimum second whole square. So the denominator is V1 square plus V2 square. V1 square L1 plus V2 square L1, right? Minus V1 square L1 minus V1 V2 L2, right? So V1 square L1 minus V1 square L1 cancel out, right? Similarly, the second term will become, again the denominator is V1 square plus V2 square, but in that case V2 square L2 would get cancelled out, yes, right? And then in that case we would be left with V1 square L1, right? Okay, minus V1 V2 L1, okay, that's fine. So basically this would mean, okay, we can take out certain terms, I suppose, or rather let's just square it, see what happens. V1 square plus V2 square whole square, okay. The numerator becomes yeah, I think we can, yeah, okay. So numerator becomes V2 to the power 4 L1 square plus square V2 square L2 square minus 2 V1 V2 cube L1 L2, right? No, three terms. V1 power 4 L1 square plus, I think I should write it in the next line, okay. So right, V1 power 4 L1, sorry, there was a mistake here. So you would be left with, if I am not mistaken, so if we multiply with T minimum, T minimum was this, so V1 square L2 minus V2 T minimum, so L2 V1 square L2, sorry for that, so V1 square L2 power 4 L2 square plus V1 square V2 square L1 square minus 2 V2 V1 cube L1 L2, okay, this is what we have. Okay, now we can take out V1 square plus V2 square and take this much, right? So let's see, so if we take just L1 square, so yes, so So v2 square into v2 square L1 square plus v1 square. Okay, so sorry, it's a quite long calculation. So we can take this term and this term, and we can take out v2 square L1 square. So we'll be left with v1 square plus v2 square, and we can take this term and this term, and we can take out v1 square L2 square. We will be also be left with square plus v2 square, right? And we can take out from these two, we can take out 2 v1 v2 L1 L2, and we left with v1 square plus v2 square. Okay, this becomes 1 by v1 square plus v2 square. So we can take out this thing common, so v1 square plus v2 square into v1 square v2 square L1 square plus v1 square L2 square minus, so this can be, this is essentially v1 L2 minus v2 L1 whole square, right? So this essentially becomes root over v1 square plus v2 square in the denominator. In numerator it becomes mod of v1 L2 minus v2 L1. This is the minimum distance between the 2 points. Thank you.